Hello, this is Bilal and I'm here to present the paper titled Strategic Prototyping of Big Data Systems. So unlike small-scale software systems, designing big data system is a challenge for software architects. This is because of numerous reasons. Firstly, the technology stack for big data is continuously changing, and with it the quality and performance metrics are also changing rapidly. Considering this fact, there are many architecture-related risks involved that are to be addressed in timely and effective manner in order to avoid long-running anomalies in the product development cycle. So there are two approaches that are being discussed in the paper that the authors have presented. Regarding these approaches, authors mentioned the criteria about when to use the architecture-related analysis alone and when to use prototyping along with it. So as I mentioned, there are certain risks involved in the development of big data systems. It is not a strange thing, as we are all familiar with the 5 V's of big data, which are volume, variety, velocity, veracity, and value. So volume refers to the vast amounts of data generated every second. Just think of all the emails, Twitter messages, photos, videos, sensor data, etc. we produce every second, and we share it as well. Then velocity refers to the speed at which new data is generated and the speed at which the data moves around. Just think of social media messages going viral in seconds. Then the variety refers to the different types of data we can now use. In the past, we focused on structured data that nearly fits into the tables of relational databases, but for big data systems we have a huge variety of data, so we cannot fit that into the relational databases. Then the veracity refers to the messiness or trustworthiness of the data. So with many forms of big data, quality and accuracy are like less controllable, as we have like lot of rubbish along with the important data in the collected streams. So just think of all the Twitter posts with hashtags, abbreviations, different text, context, then typos, and then different sort of speeches. So all that data may not be accurate, so we have to apply some schemes in order to make sure that the data is consistent. Then at the last comes the value. So it is all like having access to the big data, but unless we can turn there's like a huge volume of data, so unless we turn that data into a value, it's of no use to us. So value is important for like managing the big data. In designing the big data systems, there comes a need for frequent changes in design decisions that are volatile, since technology is subject to change rapidly, and with it all the design and architecture decisions. So for example, like due to rapid increase in the big data technologies, we have a whole palette from which to select the appropriate one for us. For example, we might want to use Cassandra, Kafka, Hadoop. Then we can decide upon whether to use databases like Firebase, MongoDB, CouchDB. So it's very difficult to decide on one particular instant that which technology combination would best fit our requirement. The big data systems emphasize on continuous running streams of data, so this gives us first evidence that to rule out the relational databases that work on the principle of like already stored data. So data is coming 24/7, and in order to analyze that, it would be a stupid decision to use a relational databases to first store all of it and then analyze, so which would affect the system performance manifolds, obviously. So if you just if you just hop over the market, you would find bunch of Java, C#, C++, Python developers, but when you set on to find the skill set for the technologies in big data stack, you wouldn't probably find the right person so easily, since a rapidly changing technology gives rise to the skill set for a particular type of skill being very rare. So if your product is already developed and running, if you lose the initial developers and designers, it would be hard to find people with the same match and same skill set in the market, and so the manageability of the product suffers a lot. And other risks involved in evolving big data technologies is the complex integration with the old systems. Obviously, these new big data technologies may not offer complete integration with the old systems, and many systems already developed may not support the libraries, frameworks offered by the big data systems, so which is an issue. So many a times you find deprecated adapters which usually fail in handling the data throughput from the big data systems. So most of the times you have to create another middleware, a layer to effectively integrate the old legacy systems with the big data systems. So there are three tasks involved for risk management. Design, which is attribute driven design approach, which is a methodology in which all the quality attributes are taken into account and business goals are set for that particular architecture phase. Then the architecture is designed keeping in mind the selected metrics. And then obviously after the design comes the analysis part. The design decisions taken using architecture trade-off analysis method are evaluated, and then with those evaluations we inhibit the achievement of organization's business goals. And the last and very important is the prototyping, which involves setting up mock-up systems to capture the performance and design metrics and work for their betterment. So there are three types of prototyping schemes used, and the authors explain in detail about when each of them is useful and effective. So the first one is throwaway prototyping. So with throwaway prototyping, a small part of the system is developed and then given to the end user to test and evaluate. The end user provides feedback which can quickly be incorporated into the design of the main system, and once it's included in the main system, the design concept, the prototype is discarded and thrown away as the name indicate. So the next prototyping scheme is the vertical evolutionary prototyping. So in this prototyping scheme, this one is basically a little bit different in a way that in this type of prototyping, the prototype is not discarded at the end, but is actually made part of the system after refining through all the feedbacks from the user. Then the third type is the minimum viable products, in which it's basically a scheme to actually create a product with like minimum features to satisfy early customers and to then use their feedback for future development of the product. So keeping all this in mind, authors proposed a risk-based architecture-centric strategic prototyping mechanism. The authors have presented a RASP-based model in which they provided some of the most important questions which helps in guiding the architects deciding about when to employ strategic prototyping for risk management. So with this, I'll finish off, and my team member Saria will continue the rest.
I'm going to talk about RASP model. RASP model stands for Risk-Based Architecture-Centric Strategic Model. Also, provide guidance on how to employ strategic prototyping for risk management. The RASP model can stand alone, but it is ideally integrated with an architecture-centric agile development methodology such as big data design. Now we are gonna to explain more about big data design and RASP model. Big data design is, contains of value discovery, which goes to innovation process, use case development, strategic development planning. It also work on requirements analysis. It contains business and innovation goals, quality attribute, big data architecture scenarios. It also work on design, and finally goes to implementation and evaluation. In the RASP there is two parallel streams of architecture analysis prototyping, and the idea is that where to choose which of these technology you want to use and when, and also figure out how they can adapt it with each other. It is highly recommended to start of architecture analysis because it's inexpensive. The process, steps for architecture analysis is identify the risk in business goals, alignment and strategy, identify the risk of missing, conflicting, ambiguous or under-specified architectural requirement. Also identify the risk for each decision made. Finally, it's about identify risk in future requirements and new goals or strategies. But for strategic prototyping, there was feasibility study and UI mockup. We do that with throwaway prototyping. Another process is technology risk mitigation. We usually do that with vertical, revolutionary and throwaway prototyping. And finally is about minimum viable product. I'm going to talk more about the process in RAS model in this flowchart. As I said, as the architectural analysis is less expensive, you're going to start with that. There is a series of questions you should ask yourself, and according to the answers you give to these questions, you will be led in the flowchart. The first question is this a greenfield system design? If not, access existing system and identify gaps that pose risk for new requirements. Then go for perform architecture analysis, update the existing architecture and select candidate technologies to replace or augment existing technologies. If that was the greenfield system, so you should perform architecture analysis and select reference architecture and candidate technologies. Then go to the next flowchart. The next flowchart is about evolutionary prototype, and here we ask about significant risk with a selected technology. If there was a significant risk, we should go to throwaway prototyping chart for each technology that poses a risk, and then go to integrate technologies, test critical functionality and quality attribute scenarios, test all of them. The next question will be, are there issues discovered with any technologies? If there wasn't any issues, we are done, and this cycle is finished. But if there was any issue, we should reconsider the technology selection and go to throwaway prototype chart again. The last chart is about flowchart is about throwaway prototyping. In throwaway prototype, the first question is that is the selected technology new on the market? If no, the next question is that are there new requirements that pose the technology in risk? If that wasn't any new requirement that pose this technology in risk, so we are done and this circle will be finished. But if that was new on the market, the next question will be, was it used successfully before for similar scenarios? I mean, the other companies used that successfully. If they use successfully, again, we are done. If not, have trusted sources proven the technology for specific scenarios. If they have proven, and we should trust on them, and so we are done. If not, we go through throwaway prototype and create mitigate scenario. So the question here is that does the prototype satisfy the specific scenarios? If yes, again we are done. If no, the next question is, are these configuration data models and requirements should be tried? If we are going to try it again, this circle will be repeated. If not, we should soften our requirements and change some of them, then repeat this cycle again. For validation, we use 9 case studies to validate RASP diverse domains, for example, network security, online open web analytics platform, and so on. There's 7 guidelines to use this model better. The first is that architecture analysis might be the only feasible option when you need to make early decisions. Second, architecture analysis alone is insufficient to prove many important system properties. Then architecture analysis complements vertical evolutionary prototyping, and also an evolutionary prototype can effectively mitigate risk if you implement it as a skeleton. Vertical evolutionary prototyping might need to be augmented with throwaway prototypes. As we said earlier, they can be complemented with each other. Throwaway prototypes work best when you need to quickly evaluate the technology. And finally, MVP is more of a business decision than a decision driven simply by technological risk. So we are going to have conclusion about all the materials we explained. Firstly, risk analysis has been advocated for controlling the evolutionary prototyping process. Also, our research results demonstrate that an architecture-centric design methodology such as BDD makes risk management explicit, systematic, and cost-effective. It provides a basis for value discovery with stakeholders, for reasoning about risk, for planning and estimating cost and schedule, and for supporting experimentation. Finally, the RAS model offers practical guidelines for strategic prototyping, combining architecture analysis and a variety of prototyping techniques.